All right. I'm being threatened with detentions, apparently. That's interesting. All right. So well, like I said, I have to put my children to bed first, and so they're in bed, and sometimes that goes a little longer than expected. So thank you for your patience. So I got to get my other computer fired up because I'm going to pull up that skills practice sheet. The person who helps you solve Yep, that's very true. I create a problem that didn't previously exist, and then I make you fix it. It's pretty awesome when you think about it. It's a great job. All right, let me see. So as some of you have figured out, if you're watching this, I've learned that you can't comment unless you're on a personal account. I'm talking to the district tech guys to see if it's possible to allow you guys access to comments when you are logged into your school accounts, but I don't know if that's going to happen. So, and I'm going to be doing the skills practice that I sent out. But again, if you're from Ms. Fitzgerald or Mrs. Steffen's class, this will still benefit you as well, because I am going to go over just a lot of the computation skills. So it's just a lot of skills and drills tonight, I suppose. Hold on. Okay, my other computer is going at a snail's pace here, so give me a second. We can't even see the side YouTube videos. Yeah, so that's what I mean, is if you're on a personal account, you might not be able to see those. Wait, that's weird. Oh, I don't know. Well, I mean, why does that matter? You don't really need those right now. Okay. And let's make sure we're keeping the chat civil, because remember, you still can receive, you still can receive detentions and stuff if you are being inappropriate in the chat. So let's make sure that all of our chatting is appropriate and on topic, and follow the rules of using any kind of tech tool that you would at school. Same deal. So, okay, I'm still looking for what I sent out yesterday. You're gonna have to give me a second. My home computer looks a little different, so trying to find things is a little bit more difficult. Hold on one second. Okay, what did I call that? Okay, give me 1 second, guys. Inequalities practice. There they are. I think this is it. Okay. Hang with me 1 second here. It's loading. You're on red though. Yeah. So yeah, other teams did have access to this. So yes, you might see people from other classes. So again, I've kind of been opening this up to other classes as well. All right. I have access to Cami at home too. That's pretty cool. All right. So I'm going to start out with some number line problems. Okay. And so this is the skills practice sheet that I gave out during class. So those of you who are in my class, this is your opportunity to get the answers correct, because you can turn this in and get full points for it. So, all right. So number one, okay, this is an inequality, and this is a skill you're going to need for your test called graphing inequalities. Okay. So, oh, good. No, you're live, I'm sure. I'm glad that things are doing okay. Do we need to do the quiz on con? Yes, you do. Okay, so here's a number line, okay, and I have that x is less than 2. Okay, so if I do a small number line here, 1, 2, 3, 4, -1, -2, -3. All right, so I'm not going to make these number lines huge. I'm probably going to just put them in the ballpark of the numbers that we're using. So in this case, we have a 2. Okay, so we're going to start at 2. I'm going to circle it, all right, because that's my starting point. So now I'm going to ask myself if I need to fill in this circle or not, okay? So in this case, I'm not going to fill in this circle because 2 is not able to be a value here, okay? So if I have just a less than sign, then I can't include 2, okay? Because if I were to have that 2 is less than 2, this is an untrue statement, okay? So I can't say that. So in this case, 2 cannot be a value, so I'm not going to fill that in, okay? So here's the trick I was teaching my class for how you know which way the arrow goes. So what I do, or the way I look at it, is if x is greater than, I always do that. If x is greater than, I always capitalize this R. If x is greater than, you go to the right. If x is less than, I mean, there's your L and R right there. If x is greater than, you go to the right. If x is less than, you go to the left. Okay, so in this case, x is less than the number that we circled. So we are going to actually shade to the left. And remember that the arrow means infinity. In this case, it's negative infinity. And over here means positive infinity. And beyond, if you're a Toy Story fan. Okay, so this is how we would graph this inequality. Is we, again, just to explain what I'm doing here, because the next ones are going to go a little faster. What I did was I saw that x is less than 2, so I circled 2. Since x can't equal 2, I left the circle open. And since x is less than 2, or less than the number I have, I'm going to shade to the left. And again, the L in less is the that's the key there. That's the clue. That's what we're looking for. Yes, thank my children for the blanket rack and the easel. Well, Mrs. Coffee for the blanket rack, and the kids for the easel. So, and this time I don't have to wipe the board with the mermaid blanket. So we're lucky in that regard too. I'm sorry to hear that, Mr. Van Diglen. Thanks for letting me know. You and I we'll figure it out tomorrow. So, all right. So we're gonna do another one, and don't forget that hint that I gave you. All right. So number 2. -5 is greater than or equal to x, okay? So the number I have here, I'm going to start there. -5, -6, -7, -4, -3, -2, -1. Okay, so we have -5 is greater than or equal to x, okay? So here's the thing. If I have that -5 is greater than or equal to -5, that's a true statement, okay? Because -5 can equal -5. So in this case, I'm going to circle -5, but I'm also going to fill it in because I can include that value, okay? So that's how you know whether you have an open or closed circle. This line right here will tell you, close the circle. If that line is gone, you leave the circle open, okay? And again, here's the reason why, is because -5 can equal -5, okay? So now that we know that, all we have to do now is figure out. Jeez. Yes, I know. I figured out who that was. You guys and your memes. So anyway, -5 is greater than or equal to x. Okay, but remember the question I asked you earlier. If x is greater than, okay, we go to the right. If x is less than, we go to the left. But here's the thing. It says greater than, but it says -5 is greater than x. Okay, but the question here is x is, in this case, less than. Okay, so x is less than -5. So we're actually going to shade to the left. Okay, and so that's how we get our answer here. I've been drowning in memes ever since I've been absent. Yes, I know it's a tough world. Is there word problems on the test? Yes, there are, and we're going to go over those in a little bit. Okay, so the other problems work the same way. I see that there's some fractions, but in a number line, so I'm going to do one fraction problem, but the other 3 you should be able to do after seeing these 2. And you can always rewind these and, relearn the rules again and then go through the next few problems. So the last one I'm going to do here is number 3. And this one says that 1/2 is less than x. Okay. What's interesting is on the number line, okay, they give you 0, 1, 2, 3, -1, -2. All right, so in this case, you kind of have to use your critical thinking skills here. Okay, they don't have 1/2 on the number line. Okay, but you can see that you have 0 and 1. You can find that halfway point there, and we can circle that. Okay, so we've circled it. We have our starting point. So now we have to ask ourselves, can 1/2 be a value? And the way we know is right here. If it's just a less than sign, then 1/2 can't be a value because, again, 1/2 cannot be less than 1/2. That's not true, okay? 1/2 has to equal 1/2, right? So in this case, I can't include 1/2. And again, there's no line here, so that's my big hint. No line, no fill, all right? So don't fill the circle in. And in this case, okay, again, that hint I'll show you one more time. X is greater than or x is less than. In this case, x is greater than the value we have, so we're going to shade to the right. There you go. Okay. Yes, you go between. Yep, good. I'm glad you noticed that. No line, no fill. Repeat that to me. No line, no fill. Well, I mean, take it easy there, Dragon 39. So, all right. So these are the number line problems. Again, you can always use this video. You can always go back and you can review the next three and use the same things I've taught you here, because you have enough information to move on with the next ones. So would you recommend taking notes? I always recommend taking notes, but again, make sure that they're notes that make sense to you. Like don't take notes because you think a teacher expects it. Take notes because you want to keep the information. So you have to write it in a way that makes sense. Yeah, I'm going to do all these pages. I just did the number line ones take the most time. So I was only what I'm going to do tonight really focuses on solving these inequalities. Okay. So I'm going to solve each inequality, and I'm going to go through my thought process for solving these, but I'm also going to go through the rules that you need to know when you are deciding which way the sign faces, or when you are, I'm trying to think. Oh, dealing with negatives. Dealing with negatives seems to be the other issue. Are you guys having trouble hearing me? Seems like someone's asking about the audio. Let me know if you can't hear me. My mic thing is working, so just let me know if there's a problem. Okay. Okay, good. All right, well, I'll continue then. All right, so problem number one. So this is part B of page 76. It says solve each inequality. And again, some of these might seem easy, but I want to just go through them. And again, if you're from a different class, this would benefit you to kind of hear maybe a different teacher's perspective. Sometimes it's nice to hear multiple ways of it being taught, because it takes maybe one way that it's taught doesn't quite make sense, but you hear someone else explain it, gives you another perspective. I definitely learn a lot of new things when I go into Mrs. Steffens or Miss Fitzgerald's room. So even as teachers, we learn different ways to teach things. So it's good that you're coming on here if you're even from another class. So, all right, let's get in here. So negative 4x plus 39 is greater than or equal to negative 29. Okay. All right. So I see a couple things. What I tell my class is get rid of the fluff. All right. Get rid of the extra stuff. If it's not attached to a variable, get rid of it. You want to get rid of that stuff first. Okay. So in this case, I have a negative 4x, but I'm adding 39 to it. So I'm going to get rid of that first. So I have a positive 39. How do you get rid of a positive 39? Well, you have to do the opposite operation. Yes, add a negative 39. Good. Okay. But if I do it to this side, I have to do it to this side. Okay. So the reason I do this is because I want that to go away. All right. So if I put a negative and a positive, they go away, but I have to do it over here to be fair. Right. I have two children. If I give one child something, I got to give the other one something. Otherwise, things aren't equal, and I hear about it. Okay. So in this case, I'm doing this to get rid of anything attached to the variable. Okay, I still have a negative 4x. All right, but now I just have to combine these terms. So when I have two negative numbers that I'm combining, I'm going to add them together, and I'm going to keep the negative. Okay, so 9 plus 9 is 18. I carry the 1, so I have a negative 68 here. Okay, let's see. Oh, good. I'm glad to hear that. So now I have to decide what to do next here. And the logical explanation here is I'm multiplying by negative 4. So to get rid of that, yes, I have to divide by negative 4. Very good. I like that you guys are actually beating me to the punch on this one. It's a little more interactive this way. So yeah, I'm going to divide by negative 4 so that goes away. And now all I have is an x. But if I did it to this side, I have to do it to this side because I got to keep things equal. Okay. So let me see. I think that's 15. Is that 17? Someone double check my math on that. I think that would be a 17. Okay. And negative divided by negative is a positive. But here is the other thing. Yep, flip the sign. Very good. You knew that. Okay. So here's the deal. All right. Whenever we are dividing by a negative number on both sides, or we are multiplying by a negative number on both sides, okay, after you do that, you have to flip the sign. Okay. And that's because if I don't flip the sign, okay, then my statement actually ends up being untrue. And I could go through all the reasons for that. But if I were to leave it the other way, if I were to plug 17 in, it wouldn't work. It wouldn't be a value I could use. So, and again, I could dive into the theory of why that is, but I think it's just really important right now to understand that, just understand the rule. If I'm dividing by a negative or multiplying by a negative, sign flips, okay, to keep the statement true. Think of it, I think I said this in class today, if you're using the time stone, to bring back vision, and you rip the Mind Stone out of his head. Yeah, cool. You got the Mind Stone, and now you've got all 6 Infinity Stones. But now you've created. There's consequences for that. Okay, now you've created a time loop. Hopefully, my theory is correct. We'll have to see in 2 months. But in this case, if you're going to divide by a negative on both sides, there's a consequence for that, and that means you have to flip the sign. So, both. I see someone asking, you flip when dividing or multiplying. Correct. Yes, either one. And again, we'll talk. There'll be times where this happens here as well. So I've talked about these rules. So now the pace is going to pick up a little bit. If you have questions, feel free to ask them, and I'll try to stop if I notice them in time. So, yep, 17 is correct. Good. I'm glad to hear it. Thank you, Ms. Murky. All right, so that was number 1. All right. I don't think of him as an android. Well, he kind of is, though. But I'm not going to get into Marvel theory and what an android actually is. I believe an android is defined as someone who is a machine that is constructed that is then given sentient life, like can think independently. So, but I mean, I don't know. You gotta look that one up for me. Oh, hello, Miles. You better wrestle next year. All right, so here we go. We're going to get rid of the fluff. Get rid of anything that's not attached to the variable. Okay, so I've got a negative 3x plus 37 with no variable, and that's greater than or equal to 55. All right, so here's your fluff right here. Okay, and we do the opposite. I'm adding a 37, so I need to subtract 37. Okay, the other way to look at this is if I have a positive 37, I need a negative 1 to cancel it out. Yep, you guys are beating me to the punch now. Very good. And yeah, I think you are correct. I think this sign is going to flip eventually, okay? So remember, if I subtract 37 here, I have to subtract it here. All right, and again, I have a positive minus a positive, so I'm just going to subtract like normal. Okay, so I have an 8. And if I make a mistake, feel free to let me know. Because I'm a human being, and it's been a long day, and it's 8 o'clock, and it's I could make a mistake today. I had to wrestle with my wrestlers today, so I'm a little beat up today as well. So, all right. So I got rid of the 37. Okay, I reduced this down, so I have negative 3x is greater than or equal to 18. All right. So, all right. Talk to me tomorrow about what vision actually is, and we'll have a debate about it. But for right now, let's continue. Okay. So I have a negative 3x. So if I'm timesing by negative 3 to get rid of that, I have to divide by negative 3. And I see Amelia said that in the chat. Nice job, Amelia. So that goes away. We now have x. Okay, I divide this side by negative 3 because if I do it to this side, got to do it to that side. All right. So 18 divided by 3 is 6. Positive divided by negative is negative. And I divided by a negative on both sides. So now my sign has to flip. All right. So the sign's going to face the other direction to keep it true. You should. You really should. You've really improved. So you should be proud of yourself there, Amelia. Nice job. So anyway, so that's how we get our answer is x is less than or equal to negative 6. Okay. Next problem. And again, we're going to do a lot of these because we're just kind of skilling and drilling here. So we got to make sure that we really understand all the rules here. And I'm hoping that you are following along on your skills practice sheet and filling in the answers because, these are free answers as I promised. So, let me see. All right. So I've got a negative 8x minus 27 is less than 5. Tell me, my friends, what's the fluff? What do I got to get rid of here? Well, I don't want to add 8. I see someone saying add 8. We don't want to add 8 because it's attached to the x. We're trying to get the x alone. So we can't add a negative 8 in this case. Yes, the 27 is correct. We want it gone. How do I get rid of it? Tell me. Yes, I need to add 27. Good. So I add 27. It goes away. If I do it over here, got to do it over here. So 27 plus 5, I think, is 32. And I bring down my negative 8x. All right, now what? What's the plan now? Anyone? Come on. What do I do now? I'm timesing by negative 8. Divide by negative 8. Very good. Uh-oh, I'm dividing by a negative. There are consequences. Okay, so x, a positive divided by a negative is going to be a negative. 32 divided by 8 is 4. I divided by a negative, so my sign's facing this way. I've got to turn it around, have it face that way. All right? Yep, very good. So x is greater than negative 4. Okay? So see, well, once you do enough of these, you start to get the hang of it, and it's not so bad. So we're actually almost done with the first page. So I got 9 more problems to go through. And we're I'm actually a little disappointed. There's not a whole lot of division ones, but I'm gonna do a couple of those this evening as well, just to make sure we have an understanding. So actually, let's do that now, because if we run into that problem, then we're gonna have a better understanding of what we're doing. I'm not gonna hate you. I don't hate anybody. I have been disappointed a time or two. What is the page we're doing? Oh, this is the skills practice that we're doing. So it's here. I'll tell you what. Let me see if I can. Here. It's this one. I don't know if you can see that. It's from Cami. Okay. So that's the skills practice that we're doing. It's in Google Classroom. It's the one that we're supposed to turn in tomorrow that I gave you. It's a Cami assignment that was it looked like a Carnegie sheet, kind of. Yep, I knew you'd know. All right. So really quick, I want to do a problem that involves division, because I feel like that this can be a confusing concept, especially for seventh graders who've never seen a whole lot of division. So I'm going to crack open my review today, and I'm going to use a problem I did today with my students. So it'll be the only one I do like this, but there is a lot to talk about with it. So have a little patience with me. Now I've done it. Hold on one second. I just almost crashed my computer. Oh my Lord. Okay. Great. Give me a second. I'll just make up a problem. All right. So let's say I have a 4 plus x over negative 8 is greater than or equal to, we'll say 24. Okay. So this is a problem I made up. Hey, my computer had it coming, first of all. Anyway, so I've got 4 plus x over negative 8, and that's greater than or equal to 24. Okay, so now x is attached to a coefficient, but we're dividing by negative 8 now. So we have to start seeing these as division problems. This is not a fraction. Okay, so again, let's get rid of the fluff. What's the fluff here? What would you get rid of first? Oh, good. I'm glad you made it back just in time. I'm going to drink some water while you tell me what I got to get rid of first. I agree. You get rid of the 4. And how do you get rid of the 4? What am I going to do to get rid of it? I'm currently adding it, and it's positive. So what would you do? Negative 4. Yep, you are correct. So I put a negative 4 here. That goes away. Okay, if I put a negative 4 here, now I'm going to reduce this down. So I have x over negative 8 equals 20. Okay, so now here's how you have to look at this. This is not a fraction. This is a division problem. So now I'm dividing by negative 8. So how do you get rid of division? How do you get rid of dividing by negative 8? You multiply. That's right. Yep. So in this case, I'm going to multiply by negative 8. The reason I do this, watch, is because it goes away immediately. And now all I have is x. But again, if I times 8 over here, I have to times 8 on the other side. Okay. So I'm going to multiply by 8 over here. But again, it's a negative 8. Okay. So 8 times 2 is 16. I add a 0. Negative times positive is negative. But here's the thing. Yes, you caught it. Flip the sign. I have to flip the sign because I have multiplied both sides by a negative number. Okay, so remember the rule. If I multiply by a negative number on both sides or I divide, I have to flip the sign. Okay, that's the only situations where that matters. Okay, so that's our answer. Okay, let me show you why this works. Okay, here's the rationale behind it. Okay, so if I have x over negative 8, the reason I multiply by negative 8 is because if I'm multiplying by negative 8, that's the same as multiplying by negative 8 over 1, right? And these are just mathematical rules that we have to understand, okay? So let's say I combine these terms, right? I have negative 8x over negative 8. Well, if I was to reduce this fraction down, right, if I was to divide the top and the bottom by the negative 8 I have, well, I would have a 1x over 1, right? Okay? So 1 over 1, okay, is the same as 1x, right? And you guys already know that 1 times x is x. Okay, so I'm showing you this because that's a lot of steps. Okay, it's a lot of steps, but what it does is it proves the point that you can multiply the top and the bottom. If you have the same number on top and bottom, then these are going to cancel. Okay, so that's why when I'm dividing by a negative 8, I'm going to multiply by -8 to cancel it out, because this is what eventually happens. You just get x. Okay? So in this case, because we know this and because your 7th grade math teacher taught it to you, all you need to do is times by -8. You know it'll cancel, so we just cross it out. Okay? But I saw a lot of people during their skills practice, when they multiplied by -8 over here, they forgot to multiply by -8 over there, and you can't cancel that off if you don't do the same thing over here. So just make sure we're not making simple mistakes like that. And I'm so glad to see some of you making a note card. That is a really good idea. I don't know why I need all these hand gestures, but I'm glad to hear that. So, all right. So I'm going to continue on with the skills practice that's due tomorrow. So I'm going to do problems 5 through 12. I'm going to do them a little quickly. If you have any questions during that, let me know. And if we have time left over, I'm happy to go over anything that you want to go over specifically. Okay. The test is on Wednesday, March 6th. So tomorrow's Friday. So you got Saturday, Sunday, Monday, Tuesday, Wednesday. So you got 5 days to study. And now you've got the live stream review ahead of time. And I think I am going to do one more for right before the test. So I've tried. We gave a survey, and it sounded like this is something that students find very helpful and they want to see more of. So I've decided that I'm going to try to do this more often. So 2 times a cycle, I think, is what we're going to do. Okay. So a cycle is like a unit. I say unit, cycle, it's the same thing. Teacher lingo, because I know you all want to become teachers. You got to learn the vocabulary to become a teacher. So, all right. I was busy too. I was a 3-sport athlete. I was in jazz band. I played 2 instruments in concert band. I played tuba, trombone. I actually played baritone too. All right. So, I had a sport all 3 seasons. So I understand that we get busy, but again, we have to prioritize. Okay. If you're a student performer or a student athlete, the word student comes first. So I know a lot of us are in that boat. So be smart about making sure your schoolwork comes first. There's times I've had to miss a practice or miss something because that schoolwork came first. So that's my soapbox. I'm going to step off for now. So I want to be an artist or a vocalist, not a teacher. So, well, why not? There's a lot of artists that became art teachers, and there's a lot of vocalists that became music teachers. Just throwing that out there. All right. But moving on. Am I the track coach? I am not the track coach, but I've talked about maybe coaching throws. I don't know if that's going to happen. I don't know if I have the time for that. But we'll see. So, I don't know. We'll have to see. I'm not sure yet, but I got a lot of wrestling to do right now. So that's where my mind's at. All right. Speaking of a lot to do, we are only on number 5, and I only have about a half an hour of scheduled time. So let's get ourselves moving here. So 59 is greater than 2x plus 45. Okay, so this problem's pretty straightforward. Not a whole lot going on. Good, you should be. We'd be happy to have you out. So we're going to subtract 45 from both sides because we're going to get rid of anything not attached to the variable. So I got my 2x here. 59, let's see. So 9 minus 5 is 4. 5 minus 4 is 1. All right, so I've got 14 is greater than 2x. So I'm going to divide both sides by 2. Okay, and x stays there. And now 7 is greater than x is what I have here. So, yep, I see you following along. Nice job. All right. Next order of business. And again, if I'm going too fast, you can always, when the live stream is over, you can pause this. You can ask questions. I see a lot of non-math questions and comments. So, I'm happy to stop if there actually is a math question or a math, comment. So, okay, this is a good one. So I have a negative x minus 4, and that is less than or equal to a negative 11. Okay, so everything here is negative. All right. So I'm going to show you something. I'm going to show you something cool you can do with this, but I'm going to solve it the traditional way first. Okay. So I've got a plus 4 attached to this negative x. Okay. So I want to get rid of that first. So I'm going to add 4 to both sides. All right. So that's gone. Don't forget to bring down the negative sign with the x, okay? And negative 11 plus 4 is negative 7, okay? Now, here's the deal, all right? Keep in mind that a negative x means I actually have negative 1x, okay? Remember that 1 times x is x. So negative 1 times x is negative x, right? So don't forget that you have an invisible 1 here, okay? Because x is not alone right now, so we're not done. So if there's a negative sign in front of the x, we have to make that go away. So I just told you that there's an invisible 1 here. So if we have a negative x here, we actually divide by negative 1 on both sides. Okay? So if I divide by -1 on both sides, the negative sign goes away. Okay. However, I divided both sides by a negative. So the sign's got to flip. And -7 divided by -1 is a +7. Okay. So don't be fooled and don't forget the rule that when you're dividing by a -1, yep, flip. Good. You guys are catching on now. Very good. So I'm going to show you something cool you can do with this problem to save yourself a little time. So again, once you know the rules, you can start to break them. You can start to bend them to your will and make problems more manageable. Okay. So let's go back to our original problem. Okay. And again, if you understand the rules, then you can do this. I can't comment quick enough because I'm doing scratch work. Okay. Well, that's fine. What questions do you have? Because I'm happy to answer any questions that you have about this. Or, I mean, I can show you this other way and see if maybe there's this, you can, well, I don't know why I'm so all over the place right now. I don't think anything in that sentence made any sense. All right. I'm tired. I got to go to bed after this. All right. So in the meantime, I'm going to show you a cool trick that you can do in this situation. So I said in the last unit that just because you can do something doesn't mean that you should. Okay. So if you are allowed to start with division. You can start with division, but that doesn't always mean that you should. In this case, though, I see that everything here is negative. Okay, so if everything here is negative, you know how we divided by -1 down here? We can actually divide by -1 right off the bat. We can divide all these terms by -1. And again, as long as I'm doing it to everything, I can do this. So in this situation, I think you should, because a -1x divided by -1 just leaves me an x. A -4 divided by -1 makes a +4. Okay. A -11 divided by -1 means a +11. And because I divided both sides by a negative, I'll just flip the sign now. Yep. Just because you can doesn't mean you should. It's one of my famous lines. That's not mine, though. I didn't invent that saying, but it's been a saying a long time. So now I've already flipped the sign, and I've divided everything by -1. So now it's a lot easier to manage because I've gotten rid of all those negatives. Okay, and now x is just going to equal 7, or be less than, or x is going to be greater than or equal to 7. Okay, so still the same kind of problem. I think I'm going to start putting a little cross on my 7s there, so we know that it's not a less than or not a greater than sign. So okay. Yeah, no, I think it's pretty cool. Like I said, once you know the rules, then you can kind of make your life a little easier. So let's erase that. We're going to move on to number 6. All right, here's number 6. That was number 6. Sorry. Here's number 7. Okay, number 7 is 6x plus 11 is less than -31. Okay, and one thing I'm going to put on my Google Classroom. Can we do a problem with parentheses? Yeah, we can do that. Let me find one that I'll make a complicated problem after this one. So, yep, I see that some people are saying you're going to add a -11 to both sides. Okay, so now I have a 6x because this cancels. Okay, and I'm going to add these negative terms together. So I have a 2 and a 4, so I have a -42. All right, and now watch this here. I'm dividing both sides by +6. So in this case, the sign is not going to flip. Okay, I'm dividing both sides, but not by a negative, by a positive. So in this case, I just leave the sign where it is. Okay, and -42 divided by 6 would be a -7. Okay, so I had a request to do one with parentheses. I'm lost. Where are you? I'm on this is problem 7 on page 77 on the skills practice I gave you. Oh, let me see. Can you do another division at the beginning with equal? Okay, so I'm gonna do both. Please, no hard problems. We're tired. Well, me too, but here we are. All right, so I'm gonna meet everyone's request here because there was a problem like this. There was a problem like this on the test. Okay, so this actually goes back to the equations test. There was a problem that looked like this. You had 1/4, and it was like 3x plus 3 was greater than, or we'll just make it a greater than or equal to. We'll just say -30. Oh no, -9. I think it was. We'll just do 9. Whatever. We'll keep the negatives out of it for now. Let's one hard thing at a time. We got to push ourselves. You're right. So in this case, when you're multiplying by a fraction, okay, if you're multiplying by a fraction, what you're actually doing is you're dividing by 4. Okay, so in this case, you're timesing by 1/4. You're finding 1/4 of this, right? That's the same thing as dividing by 4. Okay, so another way that you could write this is like this, right? So you may not know this, but now you're going to know it because I told you. Okay, is that if you're timesing by 1/4, it's the same as dividing the whole thing by 4, right? So now that you know that, okay, let's put that back. So you got a 1/4. Okay, and again, if you're doing test corrections, this will help you on your test corrections. So it seems like I would want to distribute, but again, just because you can distribute doesn't mean that you always should. So in this case, I could divide by 1/4, and the way we divide by 1/4 is we multiply by the reciprocal. Okay, so remember, if you want to divide out a fraction, you have to multiply by the reciprocal. Or in other words, like I showed you, this is the same as dividing by 4. So if I'm dividing by 4, I would just times by 4. That's why both are correct. Okay, so the reason we do this is now that goes away, and so do the parentheses. They go away. So now all I have is 3x plus 3. But if I multiply by 4 on this side, I have to multiply by 4 on that side. That's the part that people seem to forget. Okay, so if you have a fraction like this, you have a 1/4, you can get rid of it by timesing by 4, right? Because 4/4 is 1. How is your handwriting so good? Are you kidding me? That's like the worst. That's like one of my worst qualities is my handwriting. Numbers I can do. Numbers I do really well, but letters are terrible. So look at my X. It's falling apart. Anyway, so these cancel. I did it up to both sides. Okay, so 4 times 9 is 36. All right. So now it's just back to your basic inequality where I'm going to subtract 3 from both sides. So now I have 3x is greater than or equal to 33. And I'm going to divide both sides by 3. And I'm going to get that x is greater than or equal to 3. All right. So I know that was a little complicated. I threw the parentheses in there, but this is a case where you can get rid of parentheses. And I threw division in there as well. So there is a lot that's happening. But again, keep in mind that on map testing, on whatever the park test is going to be this year, I'm not sure what it's going to be called, on any of the really tough problems you're going to see in math, it's going to be an expectation that you can use fractions and decimals because you learned those in 5th and 6th grade. So you should be able to use those just like regular numbers. So it's very important that you understand the rules for using them so that you can use them to your advantage. Oh my God, what am I doing? Yes, it's 11. Wake up, Mr. Coffee. My gosh. All right, someone gets paused tomorrow. Oh, Miss Kylie, you get a couple paws for catching a mistake. Good catch. Poor me doing math. Yeah, it's rough. It's going to be called the park test. Well, I don't know it's going to be called that. We'll see. It'll be park with 3 C's. Yeah, the park test name's going to change. But you guys got to catch up. You got to read the news. All right. So we're going to get rid of this problem. We'll do another division problem at the start. So we'll start there, and then I'll do one with parentheses. Okay? Actually, I'll do the one with parentheses first because I haven't shown one of those. Okay, so let's say I have 3 x. We'll say x minus 1. We'll do a negative. We're going to use some negatives here too. Let me see. We'll do this. All right, so I made up this problem. We'll see if it works. So I have a negative 3x minus 1 in parentheses is greater than or equal to 6. Okay? So this is, again, one of those problems where I could divide both sides by negative 3 and kind of clear the table a little bit. So I could do that. I could divide these both by negative 3. All right. And again, this is a situation where that works. So I'm going to show it. Okay. Uh-oh, but I got to flip the sign because I divided by a negative number. Okay. So I'm going to add 1. So x is going to be less than or equal to 3. Okay. So again, this is a situation where I saw I had a 3 here, and I saw that the 6 was a multiple of 3. So in this case, dividing by 3 right off the bat does work. Okay, but let's go back the other direction. Okay, let's do it the way let's say we want to distribute, because you can do that too. All right. So when you have parentheses like this, here's what you have to be aware of. Okay, you have to be aware that you have a negative here and you have a negative here. Okay, because remember, when you're subtracting a negative, when you're subtracting a positive, it's the same as adding a negative. Okay, so we have to make sure that we keep our signs correct. Okay, so in this case, I'm just going to distribute. Okay, and we'll see if we end up getting the same answer here. So negative 3 times x is negative 3x. A negative 3 times a negative 1 is a positive 3. Okay, so now watch. I'm going to erase that. Okay, now we know that we understand that. That's what happened there. -3 times a -1 is a +3. Okay. And this you can distribute either way. This was one of those instances where you could divide first, but you can also distribute, and I'll show you why that works. Okay. So now I decided to distribute to show it this way. So now I'm going to subtract 3 from both sides like we do normally. Okay, so 3. I did something wrong here. I feel like I did something wrong here. I think I did something wrong earlier. I'm going to go back and show it the other way because I think I might have messed something up here. Oh, wait, no, I did it right. Yeah, no, I did it right before. Okay, sorry. All right, it's been a long day, like I said. So anyway, so now I have a -3x is greater than or equal to 3. So I'm going to divide both sides by -3. Keep in mind, though, I divided by a negative here. So my x, sign flip, 3 divided by -3 is -1. I did something wrong somewhere. Anyone catching a mistake? Yeah, do you like that dramatic pause? Because I'm really trying to figure out what I'm doing wrong here. Oh man, something didn't go right there. It's bothering me. I gotta think about this one. How do you make sure your answer is right? Here's how you make sure your answer is right. Great question. So we just got that x is less than or equal to -1. So what we're going to do is we're going to plug in -1 and see if the statement is true. Okay. So there's a good check. Let's do that. All right. So we're going to plug in -1. We're going to see if we get the right answer. Okay. And again, this side can equal 6. So a negative, oh, okay, I did do it right. Okay. So a -1 minus 1 is -2, right? And -3 times -2 is a +6, and 6 is greater than or equal to 6. So we did it right. Mr. Coffee, EXE has stopped working. I'm not sure what that means. Commercial break. It was more like a what happened. Like I just kind of zoned out trying to figure out what I was doing. This is sort of irrelevant, but also sort of just for your class, I think. But is tomorrow going to be a Mathia day? Tomorrow will be a somewhat teaching day, but then also a work day because it is the end of the trimester. So I want to make sure that you have an opportunity to get some of your work done before the trimester is over. So, all right. So anyways, that's how you check your answer. We plugged in -1. We got a -2 here. We multiplied those out. Okay, and we got the same answer. So, all right. So we did do it right. I don't know why my mind was playing tricks on me there. All right, let me just do something for my own sanity. This is really bothering me. I feel like I did something wrong earlier. Okay. What am I doing wrong here? All right, I figured out what I did wrong. So I'm supposed to be dividing here. So I should end up getting -2. That's what I did wrong. +1, x. Okay, there we go. All right. Oh my gosh, that was driving me nuts. I was like, I know I did something wrong earlier. So here's a mistake that I made that I recommend that you don't make. See how I put this line here when I divided? I forgot to do that. So what I did was I saw 6 minus 3 and I wrote a 3 because I was moving quickly. And again, I'm like, oh, I'm a math teacher. I should know how to do this. And I made an error. So my recommendation is slow down, okay, and make sure that when you're dividing, you have that division line there so you do not make the same mistake I did, okay? So I'm owning it. I understand. I made a mistake. You caught me. Thank goodness. So anyway, so I got -1 both ways. So, boy, I feel like I'm not getting this done fast enough here. What time is it? Okay, so I have 14 minutes. Oh, but I am doing some made-up problems too, so. But then again, I know I said I was going to go over all the problems on the skills practice, but I've gone over quite a few, and a lot of them are the same, and they follow the same rules. So I would imagine that you'd be able to do those other 5 problems. And if you have to go back and watch this video again, pause things, and check out those rules again, there's no problem. There's nothing wrong with doing that. So that's why he does them, because he cares. So I'm glad you see that I care. I do. I really do. I don't. I guess I don't have to do. My cat just ate my soup. I'm sorry to hear that. I appreciate you guys, being so grateful and thankful for this, by the way. I have a lot of students that tell me this is really helpful. And, I do give up time during my evening to do this because I do think it's beneficial. And I love what I do. I love teaching. And if I can help you guys out, I'm happy to do it as long as I have the time to do so. So, no, I'm happy to do it. Thank you for being so kind about it. I know that some of it's a little bit of a joke, but, I do appreciate it. I'm glad it's helpful. Yes. And I know it's cool that that students from other classes are tuning in as well. I'm really glad that it's helping. I think I get this enough, but there's another review and I can rewatch those. Okay. Yeah, that's fine. You guys can hop in and out whenever you got what you need from me. So, how does a cat eat soup? I don't know. Aren't you tired? I am tired. You can probably see it on my face. I'm really tired. Like I now that we get closer to state for wrestling, there's less and less kids in the room. So I actually have to wrestle with them a lot more. So, I get the same workout they do most days. So it's a little tiring. So anyway, and I got kids, and Mrs. Coffee works night shift, so so she's at work right now. So they're in bed. Life is good, so I've got the time. All right, that's all good. All right, so I'm going to do one more problem involving division because I think division is the thing that's confusing us the most. I'm going to slam my camera down here. All right, so let's say I have x over 3 minus 8 is greater than or equal to, we'll say, 23. I don't know if this is going to get messy or not. I feel like it's going to. So let me see. All right. So what I'm going to do is, again, I want to get rid of the fluff. I want to get rid of anything that is not attached to that x. All right. So I'm going to add 8 to both sides. All right. And we are going to get a messy number here. I can tell right away. Okay. So I have x over 3 is greater than or equal to 31. Okay. So the 8 went away. I added 8 to here. So, okay. Now, if you recall from 4th grade, I used to teach 4th grade, so I know this was taught, you learned about prime numbers. Okay, prime numbers have no factors except for 1 and themselves. Okay, now, I'm sure your 4th grade teacher made you memorize the prime numbers. Okay, so because your 4th grade teachers taught you that, maybe your 5th grade teachers taught you which numbers are prime, 31, right off the bat, you should say, whoa. That is not going to work out because 31 is a prime number, no factors, or there's no factors. Or 3 is not a factor for sure. Okay? But I just realized that doesn't even matter because we're going to multiply, so I don't even know why I got into that whole conversation. So anyway, so there, you learned about prime numbers. But anyway, so I'm dividing by 3. So in this case, to get rid of division by 3, I'm going to times by 3. It goes away. But I have to times by 3 over here. So x is going to end up equaling or being greater than 93. Okay? So in that case, we multiply. Yeah, I was losing my mind there. I'm like, why am I going to multiply? Or why am I going to divide? I'm already dividing. So in this case, we multiply. So this is math and tired joke time. Yes, I agree. This is very, yeah. It is. It is that time, isn't it? So I think I'm going to call it quits here in about 5 minutes. So is there anything you particularly want to go over? Because I'm happy to go over something that you have a question about, or maybe I didn't talk about something you wanted me to talk about tonight. I can go over anything you'd like, and I've got 9 minutes. I'm losing my voice too. All that yelling. Combining like terms. Okay. Yeah, Mr. Pickett's a good guy. Word problems and combining like terms. Okay, so I can do both of those. Let me look into the word problems that I want to go over here. Let me see. All right, here we go. All right. So here's one for you. All right. Good. I'm glad. I wasn't going to go over these tonight, but I'm glad that you asked about them because I got the time. So let's do it. So let's say you have. Okay, I'm going to take one off one of the skills practices that we did. So this one says, now you're going to see what my handwriting really looks like here. You have 4 times x plus 2 is at most 10. All right, so let's talk about at most and at least here, okay? So I'm going to bring Kylie into the mix here. Okay, that's my daughter, Kylie. She's 4 years old. Okay, and Kylie was super excited because I took her to Six Flags with my wife, and she was so excited. She was finally tall enough to go on her first upside-down roller coaster, the Demon. Okay, she was thrilled to death. Okay, now I remember this specifically here. Okay, so here's Kylie. Here she is. Okay, Smile there. Okay. She's thrilled. Okay. There's Kylie. Okay. So she wants to go on the roller coaster, right? So the roller coaster, the demon says that you have to be, here we go. You have to be at least 42 inches to ride. Okay. They said at least. All right. So that means that Kylie, will use the variable K. Kylie's height has to equal 42 inches or more. Okay. So I said that she has to be at least 42 inches tall, but that means her height has to be greater than or equal to 42. So she can be 42 inches. She could be 43 inches. She could be 6 feet tall that'd be pretty crazy for a 4-year-old. Okay. But as long as she's over 42, she can ride. Okay. Even though I said at least. Okay. So if I said at least, it means that we're looking for that number or greater. Okay. So that's important for word problems. Okay. Now I don't know about you guys. So we're going to leave Kylie there because, she looks adorable. But there is a ride. Okay, that says, okay, it has a height restriction. Okay, so if you guys know the ride Goliath, okay, so the ride Goliath, the seats are designed in a way that if you're too tall, then you can't be fastened into the ride properly, and that creates a very big safety issue because you want to be secured into a roller coaster, especially one that goes upside down. Okay, so they say, okay, and let's say that this gentleman is very tall here. And he's not happy because he doesn't get to go on the ride. Okay. So they say that at most you can be 78 inches tall to ride Goliath. So that's about 6'6". Okay. So I don't know if a lot of NBA players will be able to go on this one. Okay. So what that's saying is that, let's say a tall person, letter T, okay, they have to be less than or equal to 78 inches. So the most they can be is 78. Okay. So that's why it's facing this way, is because their height has to be less than 78 inches, okay? So, yeah, we don't want them to fall out. So they're going to say, hey, this ride's great and all, but we don't want – this is kind of a safety hazard, so sorry. And it happens. Hey, I got pulled off the Viper because I was not at least 48 inches tall when I was in 3rd grade, and I haven't – I'm not bitter. I'm a little bitter. Haven't forgotten it. And that was when I lived like an hour away. So, anyways, let's get back to the word problem, okay? Drove all the way up there watching commercials about the Viper and wasn't allowed to go on. Whatever. I'm over it. Anyway, so this one says 4 times x plus 2 is at most 10. Okay, so that means the largest it can be is 10. So that means it has to be less than or equal to 10 because 10 is the most that it can be. All right, but let's go back to what we're actually finding. So we have 4 times x plus 2. So this one's pretty straightforward. Okay, 4 times x plus 2 is at most 10. So it's got to be less than or equal to 10. Okay, which way the sign goes. Yes, and that's why I kind of had this whole conversation about roller coasters. That helps me understand. If it says at most, okay, I can't be taller than that. If it says at least, I have to be that tall or more. Okay, so that's kind of how I remember it. But let's do another word problem. There are some that are a little bit more complicated than this. Okay, so we're gonna rewind a little bit here. Get rid of all this. This is probably the last word problem I'm gonna have time for tonight because again, it's getting late and I gotta call it a day. Who has 300? That's what I said. I think. Who did I say? Who is this? Because I must have said that to you. I was like, who on earth has 300 square yards for our backyard? I want to meet that person because they got to be loaded. They got to have a ton of money. Because man, my backyard's I don't even know what mine is. Probably like 10 square yards. Oh, that's right. Yeah, I did. I didn't say that to you? I forgot who I said that to, but I was like, you pretty much have a football field for your backyard. But whatever. All right. Let's get back to the matter at hand. So here's the last problem I'm going to do tonight. So this one says twice. Let me see, twice. Oh, okay, here we go. This one's a little confusing. And this is how I'm interpreting it. So let me see, twice the sum of 13 and x is not, well, that's tricky, is not greater than 15. Okay. All right, so here's the last one that I'm going to do tonight, okay? So twice the sum of 13 and x, okay? So I have a sum of 13 plus x, okay? But I have to do twice that. So this is one of those situations where you actually have to use parentheses because I'm doing 2 times the sum of 13 and x. Okay, so I'm going to put a 2 out here because I'm going to multiply the sum of these together. Okay, so that's the expression part of this. But now let's talk about the answer, which is going to be 15, right? So let's talk about what this means. So this is not greater. Okay, so it can't be greater, right? Can't be that. So we have to do less than, but be careful here. So if it's not greater, then it can be less than, but it can also be equal to. Okay, so if it's not greater than, it can be 15, and it can be anything less than 15. Okay, so when it's not greater, then it has to be less than or equal to. Okay, so again, these word problems, you really have to slow down and think about what you're being asked to do. Don't rush through these, and don't be discouraged by them either. I know that sometimes they can be a little bit hard to understand, but when you take your time here, pull out what you can first and then kind of build around what you do understand. So I saw the sum of 13 and x. I knew that right away, so I pulled that out right away. But then I went back and read it again. It says twice the sum, so I made sure I multiplied that by 2. Right, so now I've got this whole part, and then it says is not greater than. I explained that I went less than or equal to. Okay, so the last thing I'm going to tell you is remember that for a test, you can bring a highlighter. I always recommend a highlighter on a test. When I took tests in high school and college, I would highlight the numbers I needed in math, and I would read that problem 3-4 times before I did anything substantial with it. Okay, a lot of people have this issue where they read a word problem one time. They think they're supposed to understand it right away, and then they try to solve it without rereading it. And that's where you make a lot of mistakes, okay? So again, my recommendation here is read the word problem through one time, okay? Then read it a second time with your highlighter and highlight the values that you need. And then the third time, go ahead and solve it. So before you solve a word problem, you should read it over 3 times at least, okay? There's nothing wrong with that. That's, if anything, that's encouraged, okay? So I am going to put the cap on the marker. Whoop. Wait, now I will. There we go. Okay, the marker is capped. I'm going to call it an evening here. But again, if you need to watch anything again, you can watch this live stream. It does save afterwards, as you know. Yeah, you can. There's a highlighting tool on Cami, so you can do that. But also on a test. I'm not going to – I give tests or paper, so I'm talking about on your test. Bring a highlighter to your test. So I think that's all I got. So it's been a long evening, but thank you all for stopping in. I hope it's been helpful to you. I see we had about 20 people on average, but I know people are going to watch tomorrow as well. And what are we talking about? I don't even know what we're talking about. Oh, good. I'll have to tell Mr. Piggott he's getting a bunch of good shout outs back here, so that's great. So, but anyway, good to see you guys. And again, if you're from a different class, it's really cool you stopped in. And you can always ask your teachers the same questions and go over this video again. Use it as a study tool. So, you all have a good evening. Thanks for popping in. It's always a pleasure. Have a good night.